Welcome to Emerald Hill Skies. It's kind of late to start a live stream, I know that, and it's been a long day. But this is a special day because today is the day that we were able to finally get into an observatory. And let's see if I can get the observatory picture up here for you. There we go. This is our new Pier-Tech 2 observatory, just opened today. In fact, we just finished construction and caulking just a few hours ago, and I couldn't resist going ahead and trying to get set up so that we could do a live stream here tonight. So welcome. My name's Doug Lucas, and we operate Emerald Hill Skies from the outskirts of Louisville, Kentucky. You might notice I'm kind of dressed up warm tonight. That's because here in Louisville, Kentucky, we do have some cold weather today, sorry to say. And our building, the prayer center and atrium where I normally from which I normally operate, the heat is off. So although I am inside my office, it's just like 58 degrees in here. But I do have this nice little heater down here, so that's generating a little warmth, like lighting a match. I'm gonna just check and make sure our audio is coming through so that we will know for sure. Let's see. I don't hear it. Are you hearing the audio? Surely it's out there. Ah, there we go. It is there. Okay. So you've seen the observatory. Let's now go to our screen here. I just want to quickly share a couple of the components we're working on. First, I'm trying to get in the habit of doing a title here. And so I'm just going to put in the word Messier double star, because that's what we're looking at here. And that'll hopefully kind of remind you what we're looking at there at the bottom. So that's one element of the screen, that title down there at the bottom. And then another element of the screen here in the middle will often have our planetarium software, and that's what we're looking at right now. Let's zoom in and kind of get a little close-up of what we're looking at here. This is Messier, and Messier is a double star with its double star Alcor. But what's interesting about Messier is that it's also another double star with Messier and this little star here. I wonder, let's see if we can figure out the name of that star. I'm ashamed to say I had several. Zeta Ursa Majoris. How about that? So it's a double star system. It's not only double with Alcor, but it also has Zeta Ursae Majoris as a double with itself. And then Alcor is kind of orbiting around the general mass of the three stars. So this is our planetarium software, and then you'll see over here on the right-hand side the list we're working from. You can see we're looking at Messier right now, and we'll oftentimes show some info on that. We'll put that info right here, so we'll keep it handy. Then up here in the upper right, we often have our Pegasus Astro Pocket Power Box Micro information screen there. It's kind of handy. You can see the temperature outside is 16.7. That's kind of nippy, isn't it? You can also see current voltage we're using. Then down below that, you'll see the picture of me. Hello. Then down below me, you'll see the picture of the telescope in the observatory. So let's see if we can zoom in on that a little bit. In this picture, you can see now the walls of the new scope. Is that not fun? I mean, being able to look at these walls here, and by the way, that's the moon reflecting off the walls of the observatory. Here at the base of the new Pier-Tech pier, you can see our rig rack. And let's see, I think I have a close-up of our rig rack here. It's this rack with the trip light power distribution center. Those are filtered plugs with the power supply that's generating the 12 volts, and that feeds into this this special iRig unit, and that distributes the 12 volt voltage and filters it. And also above it, you can see the Icron USB extender that we're using. It actually converts the USB signal to fiber optic digital, puts it over a fiber optic cable, and then we run it 200 feet. So the observatory is actually 200 feet out there outdoors. The telescope we're using is a RASA, pictured here. It's an 11-inch RASA. You can see the dew shield on the front. And in this little outrigger device up here on top, a little close-up on that, has a monochrome 178 camera, has its own dew strap around. And by the way, Simon, it's good to see you here. I am cold. It's just 59 degrees inside my office tonight. The furnace is down. I see here, Simon, you're saying you tried catching the observatory build, but the camera was too far away. Sorry about that. I heard you laughing a few times, but couldn't see much. Yeah, we tried to keep the camera out of the way of the vehicles and the walls. We kind of went in for a little bit more of a close-up near the end, but no problem, Simon. Thanks for giving it a try. So back here in our kind of outrigger unit, it's kind of an equipment plate, you could say. We've got that Pegasus Pocket Power Box Micro on top here, and then a Pegasus Astro USB distribution unit underneath it. And those two work together, as I explained a while ago, not only to distribute the USB signals to these various cameras, but also it's handling the power that's going scope side. And you might be interested in the camera that we're using. And a RASA, the camera's mounted actually in front of the telescope, which sounds kind of weird, but it's true. Look at the camera. It's mounted to the front of what's called a corrector plate. This is a big correcting glass out here in front of the RASA optical tube assembly. And you can see the Octopi-Astro interface there holding the ZWO ASI2600MC Pro one-shot color cooled camera there in front. It's particularly cooled tonight, isn't it? In this right-hand view, you can see the dew shield on. Over here in the left-hand view, we didn't have the dew shield on yet. But here the dew shield is in place, so that kind of gets you oriented as to what you're seeing here. That's that dew shield with the camera underneath. You'll notice there's no eyepiece, and sure enough, that's the case with the RASA. There is no eyepiece. We're looking at the star Messier through this camera in front of the corrector plate. The light comes in and is bent and comes down here at the end and bounces off of a primary mirror, and then it's collected by the camera. And you're going to see exactly what the camera sees. By the way, let's jump now to the actual image. And to do that, let's go back to our screen here. We're going to get our planetarium software out of the way. Remember, we're looking at Messier, Alcor, and Zeta Ursae Majoris. So let's look now. Here it is, this live view through the RASA. Messier Alcor. And what we'll do is we'll drop our speed down to about, our exposure down to about 200 milliseconds, and our gain down to 100. And that will let us get rid of all that glare, and we can actually zero in and see Messier and Alcor and the double star here with Messier as well, that Zeta Ursae Majoris. Now what's interesting about these stars, Messier and Alcor, is that the Native Americans used to use this Messier and Alcor as a vision test. And perhaps you can understand why it would take pretty good vision to separate this. Let's go back over to the actual SkyCam image. And if you look very closely, you can see the Big Dipper there in that image. And look at the cup. There's the actual bowl of the Big Dipper. Here's the handle, so it's actually pouring the water out, upside down. Let me see if I can get back to the screen here. So it's actually pouring the water upside down. It's always pouring into the Little Dipper. You can take these two pointer stars, and that'll let you find Polaris, the North Star, and then the handle's kind of a little bit harder to see, but there's the handle and the Little Dipper. So the Big Dipper is pouring into that. The star that we were looking at in our first view, let's see, which one is it here? Right here, yeah. Messier and Alcor then were a vision test. And when we go back to our planetarium software, you'll be able to see how to find Messier and Alcor if we just back off a little bit. Let's back off and see the asterism of the Big Dipper. So here's the bowl that we just saw, and there's the handle. And Messier is the second star in the handle. So if you look at the first star in the handle here and go to the second star, you could go outside at night, take your friend or spouse or son or daughter, and take this vision test that the Native Americans used to take. See if you can see two stars here. I honestly think it's rather difficult to see them myself, but maybe that's because my vision's not the best. But I'd be interested in knowing if you can see them, and if you are listening to this on the recording or if you're listening live, when you go out and try this, I wish you'd come back to the recording and tell me whether or not you were successful in seeing Messier and Alcor. So now what we're going to do is come back over here to this little dialog box, and what we'll do is we'll create a log entry for this. And as we do that, we're going to associate this with an observing list, and the list we're working off of is the 111 objects for light polluted skies. And you'll notice that it's picked up our observing session, which is session 54, new observatory, yay. And we'll just say here, we could split not only Messier. See, I'll get set here again. I'm going to delete that log entry because there is a bug on our planetarium software, Starry Night Pro, and sometimes it only lets us enter a certain number of letters. We could split not only Messier and Alcor, but also Messier and its closer companion, Zeta Ursae Majoris. So I'm going to save that note, and I'm going to go here to Zeta. Let's go ahead and close that. Go to your Zeta Ursae Majoris and show info there. Let's do a log entry for that. We'll just paste the same log entry in. Let's also go out here to Alcor. If we can get Alcor to show up here. There we go. And we'll do a log entry for him as well. Let's see. Oh, I see. We're actually selected the constellation. We should be able to select something else. Wonder why. Wonder why it's not letting me. Let's go to the info. Not letting me select. There we go. Now we can do a new observation of Alcor. I'm just confirming, looking up here at Alcor. Ah, we already did that one. Let's do a new one of the Epsilon. Try to get separated here so we can do an observation of this little guy. Here we go. There we go. New observation, and click that in there. Okay. Well, that's the star Messier, and let's see what else we got here. By the way, I'm going to go to here under, whoops, I don't have to do that. I'm rather going to go like this and say, add to observing list 111 objects observed. And then we'll pull Messier off of the list of our working list by going here, and we'll open up Live Skies. This is a livesky.com is a free. Oh, so sorry. Simon's in the southern hemisphere, which is why you're awake at this odd hour. Is it 3:22? Yeah, because we've changed to, what have we been in daylight savings? Now we've changed to standard, right? So it's 3:22 a.m. here now. I'm going to go to observing lists and 111 objects for light polluted skies. I'm going to see, I'm going to edit and search for Messier, right? And then we're going to delete it from this. Whoops, I don't want to, yeah, the working copy is what we're looking at here. So we're going to delete it from the working copy because we put it in the observed copy. And then we'll save. That's the way we show our observing, what's in our observing list. All right, well, yeah, Perth, Western Australia, Sunday afternoon there, 3:22. So we're exactly 12 hours opposite side of the clock. You guys can see lots of other things down there, Simon, that we can't see up here. So in a way, I guess each hemisphere has its special things. Let's see what else is available here. Let's do another sort. Why don't we try this ring nebula? It's at 22 degrees. Kind of curious to see if we can see something that low, because the observatory is 78 inches high at the wall, and the mount I'm sorry, the Pier is one of those kind that raises. Pier-Tech, you know, where it raises up in the air. But I don't think it raises quite high enough. So what I'll eventually want to do is, if you can kind of see here in this scope cam view, I want to add a spacer so we can raise the scope up just a little bit higher. But I'm interested in seeing right now if we're going to be able to see. By the way, let's just center on the ring nebula here. Center on that. So it's going to zoom out, and we're going to move over to the ring nebula. Wow, it's pretty low. Look at that. It's there in the constellation Lyra. So that's what we're going to try to see. Yeah, I bet we can't see that. I'm going to have to get a spacer so it raises the scope up, I bet. But let's try to go back and let's see. I'm going to bring up. Oh, we can see it. Look, I can already see the ring nebula live there. Let's do a plate solve on this. What that'll do is add a note to the mount so that it lets the mount know where the sky is positioned through the view of the camera. Wow, I can't believe we can see that. That's amazing. So let's put ring nebula here. What is that? What is the ring nebula? Is it 50? No, it's not 50. 50. 50. Ring nebula. Ring nebula. 57, is it? I'm trying to remember. Yep, 57. Okay, so we'll put this little observing panel there. We'll go back to our live view. So this is a live view through our RASA telescope of the ring nebula. Is there anything taking the weight of the roof when it's open? Looks like there's no frame supporting the roof. Right. It's interesting, isn't it, that well, let's get this started live stacking. Then so let's put M57 here. And let's also go to our title here down here now and put M57, the ring nebula. And we'll put here in parentheses that it's a planetary nebula. And boy, can we tell how far away it is? Let's see, 20,000. I'm not sure that Starry Night Pro tells the distance, interestingly. I'm going to have to go back out. Oh, I wonder if it's here. No. I don't think we have the distance here. I'll have to look that up in a second. But for right now, let's go back here. Let's see, screen. And let's start our live stack with our sequencer. Start imaging. This will back down our gain to 100. It'll lengthen our exposure to 20 seconds, and it'll start live stacking. And we'll let that live stack for a minute, but while it's live stacking, let's go back to our picture of the observatory. Simon has raised a really good point. In the picture of the observatory here, you can see there's no structure underneath the roof over here on the right. And the reason for that is all of this, I don't know, I kind of compare it to a nice file cabinet drawer. You know, when you pull out your file cabinet drawer from a nice ball bearing roller drawer. The drawer pulls out and there's nothing underneath it. Well, that's kind of what we have. But do remember that this roof is lighter weight than you might imagine because it's all kind of a steel that's been coated with an enamel, or maybe it's an aluminum, I guess, that's been coated. But boy, if it's aluminum, it's very thick, heavy gauge. And because there's no structure, it makes it really nice. The building is actually portable. You could disassemble it and move it somewhere else. I hope I never have to do that because of how hard it was to build it. We did build it in one day though, so I shouldn't probably complain. But that roof just rolls right back on the building, covers up the observatory. You lock the door and you leave everything set up in there. It's a lot of fun. So back to our screen now. You can see that our ring nebula is live stacking. Let's do a white balance here. Not bad. Let's pull our darks over where this crest is. Make that sky a little bit black. Let's zoom in since it's a fairly small object. How big is this object? It's just 1.4 arc minutes. So it's a very tiny planetary nebula. And the way planetary nebulae work is, as we saw in the description a while ago, around 20,000 years ago, this star was breathing some of its last dying breaths. So it shed a lot of its outer skin, its outer layers of hydrogen, and kind of boosted them out from the inner star. And when that happened, you could think of it as, jettisoned fuel. It went out in a balloon shape all around the inner star. But when that happened, the white dwarf could still operate. And we'll actually zoom in as time goes on and see if we can make out that white dwarf inside of there. Not sure we'll be able to, but I'm starting to see a little bit of it. Let's make it a little bit darker and bring our mids up just a little bit. And as time goes on, we'll use our imagination here and hope to be able to see that white dwarf inside. I don't know if you can see it or not, but there's just the tiniest speck of white starting to form up inside of there. That's at 300%. This is at 100%. So that white dwarf, it ionizes that hydrogen gas and all that dust, and it lights this up into something that looks a bit like, I don't know, a Christmas tree ornament or something with an outer shell. You can see when we blow it up to 300%, we're getting a little pixelation, but you can also start to see some of the colors. They're the reds, the oranges along the outside, and then here in the middle you can see it's kind of greenish. And right in the middle is that white dwarf star that's still operating, by the way. This is not dead. So let's come back over here and Starry Night Pro, and let's say, let's see, we could barely make out the white dwarf inside the shell of this planetary. We could see all kinds of colors, oranges, reds, and greens. Pretty interesting deal, these planetary nebulae. I think it's very unique that we can see that exploding star from 20,000 years ago. And keep in mind, it is a small object, so very, very tiny in the night sky. And we're able to see it here courtesy of this RASA 11. Let's position our darks over here. Ring Nebula. Well, let's zoom in on it here in our planetarium software. This is actually planetarium software Starry Night Pro Plus. We'll keep zooming in so you can see that white dwarf all the more here. And let's see if there's a long-term exposure, and I'm talking about a 6-hour exposure. Here you see what it looks like when you expose this object for maybe 6 hours straight. Looks like a giant eyeball, doesn't it? Very, very interesting. These planetary nebulae. All right, well, I think we're going to stop there. I just wanted to try out the telescope, make sure it was working, and as you can see, it is. By God's grace, on the opening night of the observatory, this thing is working, and you've been looking at M57, the Ring Nebula, and there it is. And boy, thanks for joining us. This has been a little bit shorter live stream, but just kind of wanted to get things kicked off, kind of have an initiation of the scope in the observatory. Why don't we slew home now? Let's see. I'm going to go back to our planetarium software and see. I'm going to go to this live sky view. We're still in the working copy of 111 objects, and let's refresh the screen. There we go. And let's go to Ring Nebula. Let's delete it from the working copy. Actually, before we do that, let's go back here and add it to the observed list. Now let's delete it from the working copy and save. So that's our workflow. Now let's why don't we go back to our, I'm gonna let you look here of a large image of the sky as we slew back, and you'll still be able to see the scope cam right underneath my picture here on the right hand side panel. And let me brighten this up just a little bit more. Let's see, it's on 2 seconds. Add just a little more brightness there, and then we'll use this panel here from the mount to, let's go back over here and stop our live stack first. There we go. Let's save as seen. Save as seen. And then we'll also save a close-up just so we've got a close-up image of this. And we're going to call that, let's see, M57 M57 on the 13th. And just to be fair, that was 31 subframes that had a total of 10 minutes exposure. And now we can stop our live stacking and go back over to our mount software for our iOptron CEM70G mount. And we're going to say go to 0 position, and you can see the scope slewing now back to the 0 position. And in the SkyCam, you can see the stars moving. And then back at our screen cam, you can see all the more it's moving in the 2600s view. So now we're pointed at the North Star Polaris again. And this is going to be so unique for me tonight. When I stop live streaming in here, I'll just walk out the observatory, unlock the door, put a lens cap on the RASA, and then lock it shut, and I don't have to tear it down tonight. And that is so much fun. It'll just take maybe about 5 or 10 minutes. I will have to coil up the fiber optic cable that we use because I don't have that buried yet. So once that's trenched and buried, then I won't have to even wind that up. But it'll take me 5 or 7 minutes to coil up that fiber optic cable. But otherwise, everything else is set up and we can leave it in the observatory. So that's kind of exciting. Thanks a lot for joining us tonight for this little shorter live stream from Emerald Hill Skies. We're glad that you stopped by on the maiden voyage of this Pier-Tech 2 Telestation 2 Observatory, and also the Pier-Tech, what would you call this, pier that raises. Thanks so much, Simon. You were live with us. Thank you, Simon. And the others that are watching us, I can see a couple of others there now in the middle of the night. And if you're watching this as recording, no matter what, we would love for you to click that subscribe button. If you like content like this, you're invited. We're inviting you. It doesn't cost you anything. And it helps bump up the channel in the algorithms of all the other users around YouTube. You could click the thumbs up if you like content like this. And we'll look forward to seeing you next time we go live here at Emerald Hills Skies. God bless. Have a great night. And I'm thanking God for this observatory. Take care, and we'll talk to you soon. Good night.